Alright, this is a video for moneyeducation101.org. This is a video about the time value of money. In this first box right here in the spreadsheet, I have a situation that can answer a very simple question of how much car can you afford with a monthly payment that you know that you can afford, or how much of a house you could afford. So if we look at this, this is a present value function. And what this is doing is it will calculate how much of a car you could afford. So let's say I could, for example, afford a $250 car payment. The number of years that I would carry that car loan over is for 5 years. And then I have a rate, which is the interest rate on the loan at 7%. And then in here, as you can see, I have a present value formula that takes all those things into consideration, and it calculates the amount of a loan that I could afford. So if I could afford a $250 car payment each month after doing some budgeting, then I would be able to afford a car that was in the $12,500 range. And obviously you can kind of play with this. Let's say you got a higher interest rate, maybe your credit score isn't as good, and they only let you borrow it for 4 years. If you could still afford a monthly car payment, you see that it of $250, you see that the amount of car went down. But as you continue to go up, you can buy a more expensive car. Such as something cool that I really like, and it's good to know. So if you could afford a $200 car payment, it shows that you could buy a car that would be about in the $8,000 range, or take out a loan for $8,000. It also works for a home as well. Let's say for a home you had a bigger budget of like $1,800, and it obviously would be 30 years because it'd be a home mortgage, and the interest rate would probably be about 4.5%, depending on, sorry, that should be 1,800. Then the total amount of home you could buy is about $355,000. So like I said, this is just something fun I like to play with, especially when we're about to make a purchase, whether it's a car or a home. It's really useful. So let's go on to this next thing. This is a future value formula. So this helps with how much will I have saved with X amount of dollars. So if you had today, if you had $10,000 that you could save or put into some form of investment, let's say you got a 4% return on that investment, and you had it invested for 10 years, and let's make the payment 0, then at the end of that 10 years, the future value, or the amount that your $10,000 would be worth, is $14,802. And so I like using this when I have a little bit of money to invest and kind of contemplate which interest rate or what I'd like to get. So let's say I wanted to put that $10,000 into a CD, and the CD only has like 1% right now, and I wanted it for 10 years. It shows that obviously I'd only make a little over $1,000 in interest with that 1%. But let's say also with that CD I wanted to make a monthly payment, which means that I could save maybe $20 a month, and I could put it into that CD as well. There's some CDs that allow you to do that. That extra $20 will help. Watch what happens to the 11,046. It went up. It went up to 13,000, so it went up over $2,000 more that you were able to make. And that's because you're applying a monthly payment that that helped accrue interest on it as well. So like I said, this is something that you can play with as well, and you can look over. Maybe you only have $1,000 and you're wondering what you should do with it. Maybe you know of an investment, or you have a friend that's starting a small business. Maybe they need a $5,000 loan to start up, and they're willing to give you a 10% back on your money. You could see over the 10 years, let's put that at 0. You see that you would more than double your money by having your money loan to that friend. So again, this is a future value formula which helps calculate the future value of what your money will be given the amount of years and the interest rate, and whether or not your also putting smaller interest rate. Let's drag this out. So let's say something small, like 1%. You see that you're only making 500 bucks. So this kind of helps. But the more you save up, maybe that's all you get. But if you can afford to put $500 a month into it, or $250 a month into your savings, you can see after 10 years your savings will be pretty big. So the next thing that I have here is a present value formula where you're trying to find out if you had in the future, if you were to look into the future and you wanted to have, in this scenario, I have $1.5 million. If you wanted to have that much money saved up, maybe at retirement in 30 years, maybe retirement's 35 years away, and you know that there's an investment where you could get maybe 10% back over those 35 years, then today, if you put $53,376 in an account or in some type of investment that received 10% over the 35 years, you would have your $1.5 million saved up. And so that's another pretty cool thing. Let's say you could also put a payment in there of maybe $200, or whatever you wanted to do. You'd be able to save up more money and earn more interest and get closer to making that future value of $1.5 million. Over here, over here I have a future value annuity. So what I have here is a little statement to save for retirement, and I've got a future value formula set up. And these are one of the things that I really like, because if I save this much per month, so if I saved $150 a month and I earned this interest rate right here per year, so 11%, like I said, you can change these to whatever you want. Maybe you're the mutual funds or whatever are giving you a 6% return and you're contributing $150 a month to them, and you're saving it for 360 months or 30 years. Then at retirement you would have $150,677. And this is just by making that monthly payment and getting that interest rate over the 30 years. So the time value of money functions are really really helpful. There's a lot of different ones. There's the like I said, I've just shown kind of the present value and the future value, and there's also payment functions. There's the NPER functions, which can show years. There's rate functions, but these are just a couple that I use the most, and I hope that you found that helpful.